Okay, so looking at this, you can see that this is x. You notice that here we factorize, and I showed you when you factorize what you get. Now we try to make this equal to 0, and you see that it's not going to work. Now let's now try to factorize x. We've factorized y, we've seen what it looks like. So factorizing x, this is going to be x into 1 plus y, so that I have 2y minus 1. So it looks like this is the one that will work. So the way to go about this is check either ways which one works well. So you know that our goal is making x subject of the formula. So to make x subject of the formula, it simply means having x here equals to dividing both sides by the coefficient of x, which is 1 plus y. So this is now the sentence as 2y minus 1 all over 1 plus y. So this is our value. So looking at this now, looking at this, looking at what we have, x equals to 2y minus 1 all over 1 plus y. Looking at this now, what are the possible values that can go into y and this way? So that if you know that, let's check. And if you know this, what are the possible values that can go into this? So let's check. I know that up here, any value you put up here can work. If I put y to be 1, 2 times 1, 2 minus 1, it will work. Any value I put for y here work. But down here, that means that up here minus 1. We will now, once you get this, your problem now is to check if it is defined up and if it's defined down. That means that here I can have this to be equals to 0, so that even if I make this to be equal this way, this would simply be 2y equals to 1, and y can be equals to 1 over 2. This can work. Then on the second part, that is the denominator part, so this is for the numerator. So for the numerator, I told you range is simply finding the values of output. So for the denominator, I know that I have 1 plus y, and anytime you have something that is denominator, know that it cannot equals to 0, because if your denominator is 0, it means that it is undefined. It cannot equals to 0. So if you know this, it simply means that y cannot equals to minus 1. So these are the possible values. These are the possible values that you have for your range. So your range is simply minus 1. Your range is simply minus 1. So that means that your y cannot be equal. So if you are writing this for your range, if you're writing this, it's simply the sentence as saying f of x not equals to minus 1. This is it. And also f of x can be equals to half. So these are the possible values you have as your range. Note it. Just know it that my final answer is this one. Why I say my final answer is this one is it is what you have on the denominator part that you normally take note of, because it is what you put here that can destroy what you have here. So if I make this to be 0, you see that everything here can't work. So my range, the output, is simply not equals to minus 1. F of x 1 all over x squared plus 1. So to find the domain, what are the possible values you can put for this x? Just know that whatever value you're putting for this x, it can never be equals to 0. X squared can never be equals to 0. Everything here, that is x squared plus 1, can never be equals to 0. That means that x squared can never be equals to minus 1. And you know that this is the same thing as x equals to root minus 1. And if I have this to not to be equals to, x can never be equals to root minus 1. And you know that this is a complex number. Complex number are numbers that are not real numbers. So that means that s can be anything real number, but it cannot be a complex number. So that means that this is the sentence interval notation of your domain is simply knowing that this is minus infinity, this is positive infinity. This means that s can be anything from this place to this place, but it can never be this. It can never be equals to root minus 1. Even s can never be equals to minus. It can never be equals to minus. It can never be equals to minus. So if x can never be equals to minus, notice something. Just be watching this. Just be watching this. If this is minus 1, it can be any real number. This is minus infinity, positive infinity. But notice that it's under the denominator. It's on the denominator part. And if it's on the denominator part, the denominator part is not supposed to carry a negative number. So if it's not supposed to carry a negative number, that means that everything on this part that is negative number is not going to be among. So my domain is simply all values that are positive numbers. All values that are positive numbers. So that is why we have it initially that this is not equals to minus 1. So in interval notation, this is simply let's say my x is an element of all positive real numbers. Because if I have this now to be plus 1 and this will give me this. If I have this, for example, and notice something here. Let's check. If I come and put minus 1 here, minus 1 squared is going to give me 1. Minus 3 squared is going to give me 3. And 3 plus 1 is still going to give me a positive number. So for that reason, x is an element of real number. So but cannot be equal to minus 1. Because when you have minus 1, it's now a complex number. Now the next part is the range. To find the range, I've told you, the minute you're about to find the range, remember that this f of x means y, so that I'll say y equals to everything I have here. Solve for it so that this becomes s squared plus 1 all y equals to 1. This is something as yx squared plus y equals to 1. Remember that our goal is to make x subject of the formula. So this is the sentence as saying x squared and 1 equals to 1 minus y. Divide both sides by the coefficient of x squared. This becomes x squared equals to 1 minus y all over y. And notice that this is the sentence as saying x is equals to square root of 1 minus y all over y. So this is now what you use to find your range. So to find my range, I know that y minus y, the one up, notice that everything here is still inside square roots, and whenever the square root is on the upper part, this cannot be, this can be greater than or equals to 0. So whatever you're solving here will be, once it's square root, it must be greater than or equals to 0, because if it's not greater than or equals to 0, if it's not greater than 0, or if it's not equals to 0, it means that it's less than, that is minus, and minus cannot be found inside square roots. Once minus is found inside square root, it's no longer a real number, it's not a complex number, so it must have this, so that y minus y is now greater than or equals to minus 1. This will divide, cancel this, so that this becomes, so the possible values that you get as your output is 1, that is anything equals to 1 and greater than 1. That is the first range for the upper boundary, that is the numerator. Then for the denominator, I have y. Now notice that since I have y there, it simply means that this is the same as y. Since it's under the denominator, it's, once it's having square roots and is at the denominator, it must carry greater than 1. So it must be greater than 1. So this is the same as saying 1 minus 1. This is the same as saying 1 minus 1 is 0 all over 1. 0 over 1 is the same as 0. Square root of 0, 0. It can work. X can be 0. There's nothing wrong with x being 0. So this is my value. So if I want to write this range now, I'll simply write f of x is greater than or equals to 1, and that is my range. That is my range. Now I have root 1 minus x squared. This is automatically, the minute you see this is inside square root, it must be greater than 0. This is the same thing as saying 1 minus x squared greater than or equals to 0. It must be greater than. So that this is the same thing as saying minus x squared must be greater than or equals to. If this is equals to, it becomes minus 1. So that this is the same thing as x squared, this cancel this, greater than or equals to greater than or equals to 1. Greater than or equals to 1. So that this is the same thing as x is equals to roots. Sorry, greater than or equals to roots 1. Note that. So if that is the case, it means that you know that root 1 is the same thing as x greater than or equals to 1. So x must be greater than or equals to 1. That's the domain. So the domain of this, the domain of this is simply, the domain is simply all values of x, all values on the real number or on the number line that ranges from 1 and above. So every number that is an element of 1 and above is your domain. Those are the values you can put in as your 1. So that if you check it now, if I put 1 here, 1 square is 1. 1 minus 1 is 0. Square root of 0 is 0. If I put 1 here, it will work. If I put what's it called, 2 here, let's check. For example, let's check, let's see, I believe this won't work, but let's check. If I put 2 here, 2 square is 4. Now 1 minus 4 is now minus what's it called, minus 3. 1 minus 4 is minus 3, and minus 3 roots is now a complex number. It's no longer a real number, it's now a complex number. So that means that what we are supposed to have as our domain, is simply noting the fact that this is having this, So in this type of question, I like to check and be sure. Notice that if I put 2 here, 2 square is 4, and 1 minus 4 is minus 3. So notice that the only value that is working here is simply for if I have 1 minus 0, which will give me 1, then I have square root of this giving me uh, still 1. So the only values of this must be greater than 1, greater than 0, greater than or equals to 0, but not greater than 1. So that means if I'm drawing the interval notation, for this domain, this is going to simply be in such a way that if I have this to be 1, and I have my negative infinity, I have my positive infinity. Now, if I'm drawing the interval notation here, it simply means that the values I can have here is simply from 0, 0, it must be 0 and 1. These are the possible domains, the possible values I can impute. So these are the possible values I can impute for x, so that this function can be defined. The minute I impute anything other than 0 and 1 inside this, I doubt this function can work. So let's find the range. For the range, we use the same formula I taught you. So to find the range, so this is your domain. So to find your range, it simply means that you remember, the minute you want to find your range, you remember that f of x is equals to y, and remember that what you have here is square roots of 1 minus x squared. Now, if you have square root of 1 minus x squared, this is something as saying take the squares of both sides, or you say this square root crossing over, so that this becomes y squared is equals to 1 minus x squared. Remember, our goal is to make this subject of the formula, so that this is the sentence y squared minus 1 equals to minus x squared. And since this is minus sign, let's divide both sides by minus 1, so that this becomes minus y squared plus 1 equals to x squared. Equals to x squared, and this is the sentence saying this is something as having roots minus, that is what the sentence as saying y squared